we are going to talk about the units, measurements, and dimensions. Basically, the past question reviews. And before we delve into solving past questions, I'm going to clarify most of the concepts you can probably meet in your exams. We've already talked about the concept of units, that it is what differentiates one physical quantity from the other. And we said, for example, I gave an example in the previous class, that imagine a teacher comes to the class and asks for blessing. Of course, if there are more than one blessings in the class, the three of them or the four or the five, as the case may be, will stand up. But what differentiates one blessing from the other is the surname. So if the teacher comes into the class and say, "Blessing Victor, stand up," Blessing Victor is going to stand because Victor is his or her unit. So bringing it back to what we have, the unit is what differentiates physical quantity from the other, such that if we have 50 Newton, it is different from 50 kg, because though both of them have the same numerical value, but the unit differentiates kg from Newton. Of course, kg or kilogram is the unit for mass, while Newton is the unit for force. Having said that, we said whatever we are doing in the universe or on Earth, we must have the idea of what measurement is, because it is what shows you how big, how long, how fat the content in a particular matter. That is what measurement is. For instance, if you want to cook a cup of rice, remember I said a cup, so it shows you the quantity of stuff, the quantity of content a matter contains. So, and dimensions actually relates physical quantities, the fundamental physical quantities, from all other physical quantities. And remember I said in my last class that we have two basic types of physical quantities, which are the fundamental and the derived quantities. And we said fundamental quantities are basically three in number, and they are the mass, the length, and the time. So how do we relate mass, length, and time to all other physical quantities? Of course, we use dimension to do that, and the process of doing this is called the dimensional analysis, which I did justice to in our previous class. So for now, we are going to look at the first question we have over here. The question states that the accurate measurement, this is a question on measurement, and it could be found in JAMB 2010 question 13. So the accurate measurement of relative density of a substance in its powdered form is done with a beam balance and dash. Option A, an Eureka can. Option B, a burette. Option C, a pipette or a pipette, as some persons call it. A pipette and a density bottle. What is the correct answer? You can't answer this question without understanding what relative density is. It is not possible. So this brings us to what relative density is all about. Relative density is the density of a substance relative to the density of a given reference material. And in some texts, they define relative density as the mass of a substance over the mass of equal volume of water. In the other way around, you can define it as the ratio of the weight of a particular substance to the weight of an equal volume of water. So whichever way you would like to describe what relative density is, the most important thing is to note that it is the ratio of a particular characteristics of a substance relative to another reference material. And in most cases, the reference material is a universal solvent, which is water. I said in most cases, not in all cases. Okay, now going back to our question, we said the accurate measurement of the relative density of a substance in its powdered form. In its powdered form, one of the things that makes us to identify or know the type of measurement to use is the state of the matter. What we use to measure liquid is different from that which we use to measure solid, and so on and so forth. So the state of this substance is in its powdered state, in its powdered form. So the next state to note is what is an Eureka can. Like we have here, an Eureka can is a particular can that is so large enough to measure the weight of any substance, most cases solids, that is dipped inside. The can is filled to the brim with water, and substance to be measured is dipped inside, just like we have in the second picture over here, the second image over here. The first image shows the Eureka can and the particular water, the particular level of water that we have. So when we dip the stone inside the can, the container, the stone will displace some amount of water, and this water will pass through this spout. It's like a funnel-like structure, which is then linked to a measuring cylinder. So the volume of the object is equal to the volume of the water that is being displaced by the can. Okay, so that is one of the ways we use to measure the weight or the volume of the weight of a particular substance. So the bigger the substance, the more volume of liquid displaced. Taking it back to our question, of course, the problem is to measure the relative density of a substance in its powdered form, and Eureka can cannot help us with that, as most likely the substance you measured using an Eureka can are solids. So we cannot use the Eureka can to measure this particular thing. That is why we will now go to the next option, which is a burette. What then is a burette? A burette is a graduated glass tube with a tap at one end for delivering known volumes of liquid, especially while doing titrations. And I'm sure most of us are familiar with titration. There's no way you would even pass your ordinary level degree without doing titration. Okay, so I'm sure looking at the image we have over here, I'm sure we've used something like this before. Okay, so this cannot never be our answer, because we are actually looking for that particular accurate measurement for a powdered form. Of course, if you are conversant with a pipette also, realize that we cannot use a pipette to measure the particular substance we are talking about. And let's check the last one, a relative density bottle. We said relative density bottle measures the mass of a substance and the mass of equal volume of water by filling the bottle with the powder and water respectively. So this has even given us a clue to the answer. We have with the powder and the water respectively, and weighed with a beam balance. So going over to the question, we have our answer already, which is the relative density bottle. So the final answer for number one question is relative density bottle. Going over to the second question, it states a hydrometer is an instrument used in measuring dash. Option A, the density of a liquid. Option B, relative density of a liquid. Option C, relative humidity of a liquid. And D, vapor pressure of a fluid. And you know that fluid is the when we talk about fluid, we're talking about both gases and liquids. What then is a hydrometer? A hydrometer is simply a device used to measure some characteristics of a liquid, such as the density, the specific gravity, and so on and so forth. So looking at the question, what is our answer? It is not far-fetched. The answer is the density of the liquid. You see the reason why we take our time to explain those basic concepts, so that whenever you see a question, you know the angle or the approach to use. Having said that, the question 3 over here is, in order to measure the error of parallax while taking measurements with a meter rule, the eye should be focused A, slantingly towards the left of the markings, B, slantingly towards the right of the markings, C, vertically downwards on the markings, and D, vertically upwards on the markings, just as we have seen in JAMB 2012 question 2. Before solving this, or before approaching it, what is parallax error? I'm sure while growing up, while in my secondary school days, most experiments, most times they ask you to find the precautions used in so and so experiments. So without even thinking it twice, most times I would just write error due to parallax, avoid errors due to parallax. And I'm sure most of you have that experience also. But what then is parallax error? Parallax error occurs when the measurements of an object's length is more or less than the true length because of your eyes being positioned at an angle to the measurement markings. So while taking measurements on a or from a meter rule, it is advisable to stand vertically, to focus your eyes vertically downwards on the markings, so that there would not be any displacement of the liquid by your eyes, because your eyes might see it slightly above or slightly below. Okay, so to avoid that, you have to focus your eyes vertically downwards on the markings. Of course, it cannot be vertically upwards. Slantingly towards the left or right is not acceptable, because that is parallax error itself. In order to remove that, you have to focus your eyes vertically downwards on the markings, and this gives our correct answer to be option C. Okay. A quantity which requires magnitude and direction to be specified is dash. A, the temperature, B, the distance, C, displacement, and D is the mass. Invariably, what this question is asking us is to find a vector quantity. Which of the following is a vector quantity? That is the other interpretation of this question, because vector quantities are quantities that are specified by both magnitude and directions. So amongst these, which is a vector quantity? Of course, temperature only shows us how hot or cold a body is. It does not have anything to do with the direction. The same thing, distance. Distance and displacement are almost the same thing. The difference between distance and displacement is that one is a scalar quantity. It deals with the length or how big a particular quantity is, while displacement shows us the length as well as the direction in which the body is moving. Of course, mass is a fundamental quantity. It just shows the magnitude. So that gives us D as our correct answer. So the quantity which requires both magnitude and direction to be specified is the displacement of that particular body. Now, a similar question to the 5th question we solved is this: which of the following is a vector quantity? I just discussed what a vector quantity is that it is a quantity that has both magnitude and directions. So electric charge, electric potential difference, electric field, and electric capacity. Which of them is a vector quantity? I'm sure you have your answer already. The answer is, before I tell you the answer, let us explain what electric charge is. We say electric charge is the physical property of matter that causes it to experience a force when placed in a magnetic field. So this is what electric charge is. From the definition, you should know that electric charge does not have direction. It's just a property of matter. Is that okay? Now, going to the next one, which is electric potential difference. It is also known as the voltage of a particular body, which is the external work needed to bring a charge from one location in space to another. Is that okay? The external work needed to bring a particular body, a particular object from one point to another in an electric field is called the electric potential difference. From this also, you should know that it is not a vector quantity. It does not give direction. The third one is an electric field. It said it is a region in space around an electrically charged particle or object in which an electric charge would feel force. From that, take note, would feel force. And force, like we know from second law of motion, Newton's second law of motion, it states that it is the product of mass and acceleration. Mass is a scalar quantity, while acceleration is a vector quantity. That makes force a vector quantity. And if electric field deals with force, invariably we can deduce that electric field is also a vector quantity. But let's see what capacitance is. It said it is the ratio of the amount of electric charge stored on a conductor to the difference in its potential. So we have our answer already as the electric field. To buttress on that, an electric field is a vector quantity and can be visualized as arrows going towards or away from a charge. Let's say this is the charged body. It is either moving towards or moving outwards or away from. Okay, so we have, since it describes the direction of the movement of the charges, then we say electric field is a vector quantity. We have our answer already as electric field. The next question is, which of the following is the dimension for pressure? Dimension for pressure. In one of our previous classes, we discussed dimensional analysis, and we said one of the applications of dimensional analysis is that we use it to dimension a particular physical quantity. So we want to use dimensional analysis to know the dimension of pressure. But before doing that, I'd like you to note that pressure is equal to the ratio of the mass of a particular substance to the volume. And we said dimensionally, mass is capital letter M and V is volume. Volume measures the length, the breadth, and the height of a particular solid. So we have to relate length, breadth, and height to the three fundamental quantities, which are the mass, the length, and the time. So since length, breadth, and height measures linear distances, we can relate it to L. Therefore, we have our pressure is equal to M over L raised to power 3. From law of indices, we can say that it is equal to ML raised to power minus 3. And this gives our final answer. That gives us our final answer, ml raised to power 3. Okay, the next one is we have the internal diameter of a small test tube can be measured accurately using a dash, A, micrometer screw gauge, B, the pair of vernier caliper, C, meter rule, D, pair of divider. And this could be seen in JAMB 2017 question 19. What we are asked to find is which instrument can we use to measure the internal diameter of a very small test tube. Very small test tube. Of course, the material we want to measure determines the type of apparatus to use in measuring them. So, what do we use to measure the internal diameter of a very small test tube? This takes us to the description of what a micrometer screw gauge is. We said it is a device or an apparatus used to measure smaller lengths or distances more accurately than its counterparts like the meter rule and the rest. So that is what a micrometer screw gauge is. But our question is the internal diameter, not small length. So of course, micrometer screw gauge is out of the way. A vernier caliper is used to measure the internal diameter of pipes and cylindrical light-shaped bodies, and that gives us our answer, because our question is to find the internal diameter of a small test tube. A test tube is just like a small cylindrical body. So the answer is option B. Meter rule measures linear distances. Pair of divider also measures linear distances. So with these, I'm glad to announce to you that we have come to the end of the class on the past questions review for units, measurements, and dimensions. In our next class, we'll look at other concepts